Hello? 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 Yeah, lower lights would be good. Then no lights. No lights. Yep. I see. Alright, then just kill the lights. Like, yeah, this should be fine, I think. I apologize in advance if it isn't too good. Yeah. Yeah, so I'll just be talking about what's in the future is death. So how long do things usually last? When was humanity the closest to extinction? Like what could have brought us to extinction? Then we've done it in many forms. Then how many creatures have actually gone extinct? So basically, from over here, this one is basically like one of the discussion ones. Then so this one is also another discussion. Basically, what we should think. So basically, given the constraints of the talk, because I'm going in depth into each one, I'm going to be considering intrasolar system. Hmm? Hmm? Sorry? Yep. Hello. Yeah, content. Okay, right. Right. Good evening, everyone. My name is Bharat Shankar, and today I'll be giving you a talk on. I'll be talking about space exploration and colonization and possible future colonization. All right. So let's just begin. So this is our first session after a long time, but enough of talking about the past. Let's see what the future has in store for us. And wait, what? Oh, wait, wait. Does the clicker work? Yeah. All right. We'll see what the future holds for us. And okay, it's not too optimistic. All right. So the thing is that everyone dies eventually. Like without exception, humans die. Humans are temporary. Right. So, but will humanity as a whole last? So let's think about a proxy for like humanity as a whole. Let's think about individual great empires or civilizations. So you basically have like the Ottomans, you have the Ottoman Empire, which spanned over this general area and lasted over 600 years. Then you have the longest lived empire on earth, that would be the Roman Empire, which lasted 1,500 years. Yes, I know there's some splitting with Byzantine versus Western Roman. I'm considering both to be the same state. Now, when was humanity the closest to extinction? Uh, so, would anyone like to gather a guess? Like, what was the lowest population of humans at a given point of time in our species history? 100,000. Any other guesses? Like, it's okay. Take a guess. So you might think like what, like 1,000, 10,000, a million? The answer is about 600 people. This was around 195 to 123,000 years ago. The entire human population is alive today because these 600 people didn't pass away before they had kids. So now we've run into many, many close calls. There was a super volcano eruption around 70,000 years ago that almost wiped out humanity. Oh, wait, what? What's happening? Quite intriguing. All right, we've run into many, many close calls. There was a super volcano eruption around 70,000 years ago that almost wiped out humanity. We've almost gotten into nuclear war quite a few times. There's basically, I can recall, off the top of my head, I can recall two separate occasions where either nukes were accidentally deployed or nukes were deployed in response to a threat that turned out to not really exist. The case of Stanislav Petrov being one of them. Now, you also have plagues, which definitely won't happen again, right? There's global pandemics are definitely not going to happen again. Heavy sarcasm, heavy sarcasm. Anyway, for context, the bubonic plague wiped out over half of Europe, and yeah, then you also have meteor strikes. So the uh, everyone's seen the one that happened in around 2013 in Russia, right? Around 100 years ago, in the early 1900s, a meteor crashed in Tunguska in Russia. So it killed quite a few trees. No one was killed, thankfully, because it was in a very remote area. The chances now that humanity has become more and more industrialized and more of the planet has been densely settled, the chances of it landing in a more desolate area are becoming more and more remote. All right. So now you might think, okay, fine. Okay, fine. Uh, how many creatures have actually gone extinct? Like, it can't be that bad, right? What proportion of all creatures have gone extinct? Anyone want to take any guesses? 98%. Anyone else want to take a guess? 50%? You? More than 75? 90? Anyone? 20? All right, the answer is 99.9%. Over 99.9% of all species that have ever lived have gone extinct. This includes all of the dinosaurs, this includes tens of thousands of fish species, hundreds of millions of bacteria species, quite a few mammals in there. So, anyway, fine. Just to put that into context a bit more, you see that tiny, tiny blue line over here, the slight thing that's just scarcely a few pixels. That is all 7 million species currently alive on the planet today, in comparison to all of the other dead ones. So statistically, humanity doesn't really have a good shot now, do we? So why don't we think about how humanity could go extinct right now? Actually, I would like if everyone would just discuss with the people around them and then just come up with ideas as to how humanity could go extinct. Asteroid impact is one. I heard meteor. Global warming, climate change, World War III, yes. Pardon? Yeah. Wait, what? Oh, cats taking over the universe. That's a creative scenario. Yes, maybe. You never know with these things. Anyone? Any other guesses? Ah, yeah, so you have the global pandemic, then you have asteroid impact, you have gamma ray bursts, uh, which are basically like a huge ton of gamma rays that come from a star. They can happen basically at random, and then they can basically strip off the entire or the Earth's ozone layer, and then goodbye life. Then you basically have anthropogenic climate change. You have the possibility of AI going all Skynet on us. And then you also have super volcanic eruptions. This is the Yellowstone. This is the super volcano at Yellowstone National Park in the U.S. It may be due for an eruption sometime in the next few thousand years. If so, it would release a ton of volcanic ashes and stuff that would basically cause a sort of like that would basically cause a sort of global cooling in some aspects, and it would also kill a ton of life. Humanity was almost driven to the brink by another supervolcano eruption. Don't forget. So, how do we deal with this issue? Humans statistically are likely to not really make it past the next few million years. So, how do we ensure that humanity survives? Well, if we want to ensure that the value of an investment survives, we diversify it, right? We don't put all of our money into one Dogecoin. We put our money into hundreds of different cryptos and then see whether or not they survive. Well then, with a similar, well then, we'll use a similar mindset. So let's not put all our eggs into this one basket. Let's try and see where we can settle. All right, so where can we go? So we have two main options, right? So we have places within the solar system and we have places outside of the solar system, right? All right. So let's just look at the pros and cons. Solar system, the pros of being inside the solar system are that, yeah, the travel time is much lesser. The inner planets take about a few months to reach, the outer planets take a few years to reach. And then one other consideration that we also have to keep in mind, because many of these colonies will not be at first self-sustaining. They will have to they will have to keep contact with Earth constantly, right? The thing is that light takes a certain time to travel a certain distance. So right now, whenever I shine the laser over there, it's basically imperceptible because light travels so damn fast. But at the distances between planets, that becomes an issue. So for example, for light to travel from the sun to the earth, it takes it about 8 minutes. So this holds true for all electromagnetic radiation. So now within the solar system, the time spans are a bit okay. Like they're within a couple of hours, which is fine. This will not be the case in interstellar space, where you'll basically have to guarantee that the colonies will be self-sustaining without any contact with Earth due to the massive scale of the distances involved, right? All right. And then the other fact is that we simply know more about the solar system rather than many exoplanets orbiting in interstellar space, right? All right. So now, about the travel times for an interstellar space voyage. If I remember correctly, the fastest probe launched was a probe launched around the sun in 2018, and if we wanted to use that probe to get to uh, to get to the nearest star, Alpha Centauri, it would take us around 12,000 years to get there. So that definitely is not feasible at all right now, unless we do something like a generation ship, which due to time constraints we'll probably not be able to go into today. So yeah, so solar systems basically are bet for the next 100 years. Like interstellar space might be happening in the next 1,000 years, but we really can't say anything. So let's think about what humans need to live. What do humans actually need to live? Food, water, then oxygen. Anyone? What else do humans probably need to live? Gravity, interaction with other humans. Yes. Then yeah. So I think that's the all right. So there are a few more over here. So basically, we'll need a source of energy, right? We'll need a source of heat. Then we'll also need to basically maintain our habitats at a livable temperature, right? No one wants to live at 40 degrees Celsius, let alone 400 degrees Celsius. Then one overlooked fact is the fact that we are actually being bombarded every single day by stuff that could kill us. So the thing is that the solar wind is made up of a ton of charged particles. So this sort of radiation can actually harm humans quite a bit. The reason why we don't have to run into it most of the time is because the earth is actually protected by a very strong magnetic field. most many places, as we will soon see, do not have this luxury of a magnetic field to protect from solar radiation. So that is also one thing that we need to keep in mind. So just for like a quick thing, this is Maslow's hierarchy of needs of a human over here. So yeah, you can see that everything just ends up falling into this. You have physiological, you have safety, you have love slash belonging, you have esteem, and then you have self-actualization, whatever that is. Then, so let's think about places where we can go in the solar system. So anyone want to suggest any candidates? Mars, all right. The moon, yes. Anyone else? Europa, all right. Then, sure, sure, sure. All right. So let's just keep this short. So for the purposes of this talk, we'll be exploring three places: the moon, Elon Musk's favorite Mars, and Venus. I know. I swear I'm not crazy. Okay. So now let's talk about the moon. So what do you think we'll encounter on the moon, right? So the moon is the closest celestial body to Earth. There's basically no atmosphere on it. That also means that the temperatures vary a ton. It goes from 400K on the bright side to 100K on the dark side. That's minus 173 to about uh, plus 200 degrees Celsius, if my math hasn't failed me yet. Okay, the gravity is about one sixth as much as that of Earth. The water is located in the form of ice on the lunar poles, more so in the south. The moon does not have a magnetic field of its own. The moon, however, presents a unique opportunity as it is rich in helium 3 as a result of being pelted with solar radiation. And helium 3 is actually a potential fuel for future nuclear fusion reactors. The travel time to the moon is about 3 days with current technology. Now, let's talk about the challenges that might be presented on the moon. So, one is definitely no atmosphere. So, that basically means that there's no protection from UV radiation. You don't have an ozone layer. It necessitates a pressure suit and a constant air supply for everyone involved. Then the low gravity can also cause bone and muscle atrophy for long-term settlers because without a lack of gravity, your bones and your muscles basically start to degrade. That is why many astronauts in who are doing long-term habitation in space have to exercise a ton. It's to make sure that their muscle mass doesn't degrade. Even then, people after 300 days have to spend significant amounts of time recuperating on Earth once they come back to adapt to the gravity on Earth. The lack of magnetic field is a real issue because it leaves the moon vulnerable to solar wind, and that can really raise one's cancer risk. And it can create extremely high amounts of charge near the polar craters. So think about it like a static shock on steroids. That's the best way to vocalize. That's the best way to think about this. Has anyone ever played the game Portal 2? Anyone? You'll remember that you remember that one of the people in that game, Cave Johnson, basically started dying of some unspecified illness after dealing with moon particles, right? Well, then he might have been actually been referring to lunar dust. So these are tiny razor sharp particles that just cling to everything. So what ends up happening is that if you start inhaling it, it can basically cause lacerations in the lung, throat, nose, everywhere. So that basically leaves you more vulnerable to cancer as the cells have to regenerate. And if they regenerate more, they're more likely to have those errors that result in the formation of a tumor. Right. So this is about the size of, this is one of those particles that's 100 micrometers to scale. Now, let's talk about the current efforts to colonize the moon. So Roscosmos and CNSA, the Chinese Space Administration, started a work on the ILRS, the International Lunar Research Station. The construction is set to begin in 2026 and it's to be completed by 2036. NASA also has plans for the lunar outpost under the Artemis program, which wants to get people back to the moon by 2024. The lunar surface acid, which is currently planned for 2028, would be a sustained settlement on the moon. So we have concept art of these two over here. Now let's move on to Elon Musk's favorite, and that would be Mars. All right, so the temperature on Mars ranges from 294 Kelvin to 130 Kelvin, and the average temperature is about 210 Kelvin. The thin atmosphere of Mars is, yeah, it's very, very thin. It's just 95% CO2, 3% N2, argon, and then traces of other gases. The surface gravity is about 30 to 40% that of Earth. The average atmospheric pressure is about 0.6% that of Earth, so you'll need a pressure suit. It doesn't have a magnetic field because this magnetic field died a long time ago. It has a large amount of ice at the poles, and there is a possibility of subsurface ice being discovered on Mars. However, the Martian soil contains a lot of perchlorates. Um, People have seen a Martian over here, right? There is a slight inaccuracy in the movie because this fact was simply not known when the book was actually written. The thing is that Mars's soil has a large amount of perchlorates that are present inside. So what ends up happening is that the perchlorates are toxic, one, to the plants and to us as well. And since the perchlorates are highly soluble, that would basically mean that any plant and the Martian soil is wholly unsuited to agriculture. However, good news, there is a fix for this. Since the perchlorates are highly soluble, you just have to run the Martian soil through some water, and then they will get, and they'll move out. Now, let's look at the challenges of colonizing Mars. So you have a very thin atmosphere, almost no protection from UV radiation, and you'll need pressurization and an air supply. Again, the dust storms on Mars can cover the entire planet, and they can last for months on end. So this is just to compare and contrast how a dust storm can completely change the surface of Mars. So there's no magnetic field, so it's open to solar wind, and Mars is actually pretty cold most of the time. Like I know that the peak can be around 25 degrees Celsius, but most of the time it's sub-zero and way below sub-zero in most of the time. So it's basically like walking through red Siberia. So here are some proposed programs. So you basically have the Aurora program put forward by the ESA. They're planning a manned mission to Mars by the 2030s. CNSA plans to send humans to Mars by 2033. NASA has plans for the Orion multi-purpose crew delivery vehicle. So the first mission of that is planned for the 2030s. And of course, we all know what Elon Musk wants to do. So they're expecting a manned mission by 2026. Now, as for Venus, the planet that is called the most beautiful of them all. It was the second closest planet to the sun, and it has the densest atmosphere in the solar system. Too bad that the atmosphere is 96 CO2, 3% N2, and the surface pressure is 96 times that of the Earth's atmosphere. An interesting fact about Venus: a day on Venus is longer than a solar year on Venus. The day is around 225 days. The solar year is around 204. A day is around 243 Earth days. A year is around 225 Earth days. Venus basically rotates extremely slowly. That slow rotation speed means that it has no magnetic field. So the average surface temperature is around 400, is above 400 degrees Celsius. It's hot enough to melt lead. Many Venera probes, which were sent to the surface of Venus, just were built to withstand those temperatures and pressures. Failed after 30 minutes. The longest thing that they've ever gotten to last was about 37 minutes, if I remember correctly. Now, there is cloud cover present, and it does rain on Venus, but it's too bad that it's made out of pure concentrated sulfuric acid. Truly a wonderful place for humans to live. Now, so here are the challenges. So we have immense pressure. You have extremely high temperatures. You have a crushing atmosphere. You have sulfuric acid raining down from above you just to hammer that point home, which is extremely corrosive. And there is absolutely no water present on the surface. However, there is a way. Now, in the near future, settling the surface of the Venus is a lost cause. But then we could try and create floating cities on top of the cloud layers on Venus. This is an actual thing that has been proposed. The reason why this might work is that these cities can actually be held afloat by breathable air, because breathable air is actually of a lower concentration, is actually of a lower density than than the surrounding Venusian atmosphere at that layer. The temperature would be around 70 degrees Celsius, which not great, but okay with sufficient protective equipment. And in the far future, we could try and attempt a full-fledged terraforming of Venus. Now, in conclusion, there are many more proposals for space colonization. Like there are proposals for settling Europa. There's proposals for settling in the Lagrange points. Then there are many other proposals out there for the solar system. Many problems and issues with the colonization are still open. Like we really don't have very many good solutions for a lot of the problems listed over here, and we'll need to find more solutions in the future. For the next few decades, we are unfortunately stuck on this wet rock. So in that case, let's take care of this one world that we do have and ensure that we don't die out before we can move on to other worlds. Well then, that's the end of my talk, and thank you very much. And we'll be having a bit of a Kahoot to ensure that you were listening in. Wait, what? Anyone else want to join? If anyone else wants to join, please join now. Right, we'll wait for a minute or two before we start. Just a very quick one, like just 6 questions we can blaze through it. Alright. We'll be locking the room anytime now. Alright. What was the lowest total population of humanity? So, what was the number of people that were left at the lowest point? Alright, promise everyone got it? Yep. Alright, let's move on. Atmospheric pressure is unsuitable for human habitation. Now, keep in mind this is a multi-correct, so be yeah, just above the Venusian cloud layer, the surface pressure isn't so bad. All right, true or false? Venus experiences rain. Yep, true. true. Venus does experience rain. Too bad the rain sulfuric acid. What a beautiful planet. Let's move on. Martian soil is unsuitable for agriculture due to the presence of. Yep, correct. It's unsuitable due to the high presence of perchlorates. Right, next. A lack of gravity produces no negative effects for humans. Yep, false. Alright, this is pretty. Venus is closer to Earth than Mars. True or false? On average, yeah. Right. Good. Any feedback, criticism, comments? Yes? Interesting. But then, like, a lot of the factors that make them uninhabitable also make them more interesting to live on, right? But then, if that were the case, I would probably want to live on Venus. If it became habitable to surface. Yes, they're not very familiar. I'll have to get that. There are plans on terraforming, but then those are very much in the realm of speculation as of now. Because the thing about Venus is that the reason why it got stripped of so much of its water and stuff like that was because the planet actually didn't actually revolve that much, so it didn't have a magnetic field. So the sun basically it off the stripped it off all the whatever thing. Okay, so basically what ends up okay, so basically what ends up I'll get back to you on that. Next 4 years, probably not, but in the next 20, who knows?
Thank you, Bara.
Alright.
Your talk was very entertaining. So now we're having stargazing session at Engine Bridge. If y'all don't know where it is, wait, tell me you're going there, right? Now? Or contact, you're going there now? Okay. Right, yeah. I will show you all the way up. So you can go now, or you can just sit down and chill. The equipment are all set up already, so you can just sit up now.